Today we are going to look at area of polygons. So before we get started, I want to remind especially my students that almost all of the formulas that we're going to be looking at here can be found on our state formula sheet. And here is our state formula sheet, the 2016 version, which is current as of this recording. So I will put a link to this document in the video description below, but you definitely want to have this handy. So you can either print it out. I have it also a link to it on our online classroom, but I just want you to be aware that almost all of them are there. Almost. But let's go back to our presentation chart. So here are some of these formulas that you need to know. We have area of a rectangle, base times height. And base, again, is just the side names. So we're calling this one base here. We're calling that one height. Parallelogram is the exact same formula. It's also base times height. One way to maybe remember it is to kind of think of this little section here where I dropped in altitude to make a right triangle. If I were to cut this out and then move it over here, you would actually get a rectangle. So that's why the area is still base times height. And triangles are 1/2 base times height, where you pick a side to be the base, and the height is just go to the vertex opposite that base, and then you just drop an altitude. So in this particular drawing, here's the base. I could have easily said, why don't you make this one the base? And maybe I'll do that in a different color. If I choose this one as the base, then that would be its height. Or maybe I wanted to choose this side as the base, then that would be its altitude. You have choices, and it makes sense depending on the example that you're looking at. I'm going to get rid of some of this because it's kind of confusing. It's 1/2 base times height because if you were to say, make a clone of this triangle here and then put it over here, you get a parallelogram, which is base times height, but I really only want half of it for triangle. So that's why it's 1/2 base times height. We have a trapezoid. So I suppose this is the official version of the formula. It's not really how I think about it because I can remember base times height, and trapezoids are kind of base times height. It's just that we have two base lengths. We have a base 1 and we have a base 2. So we're going to take the average of base 1 and base 2. And how do you take an average of two numbers? You add them and divide by 2. So when I write this formula, I usually don't write it in the form shown here. I think of it as base times height. So my area will be 1/2 base 1 plus base 2. I think of that as like base, and then I multiply it times height. Either way is fine. It's just if you see me writing it that way, that's why. Now the rhombus and the kite, here's the tricky bit. This one is not on the geometry formula sheet for Virginia in the 2016 version of our state standards. So these ones you're going to have to remember. Fortunately, they're pretty simple and they're the same. So rhombus and kites have the same area formula. You have to know how to find their diagonals. So d sub 1, d sub 2 stand for the diagonal lengths in both of these formulas, and it's 1/2 diagonal 1 times diagonal 2. So diagonal 1 times diagonal 2, take half. Diagonal 1 times diagonal 2, take half. So again, this one is not on the formula sheet. So you're going to have to remember that. I do find for some reason students tend to remember there being a plus in here somewhere. There is no plus. It's all multiplies. 1/2 times d1 times d2. Now there is a proof for that, which I'm not going to go into on this video in the name of keeping this as short as possible. But you can, especially if you're one of my students, you can find the PDF version of this that does discuss the proof. I'm going to look at some examples though. Find the area of a parallelogram. This is a very simple thing, most of these, and you're going to want to be tempted to just run right to the calculator and type stuff in. I'm going to caution you not to do that because I want you to practice the process of this, because when we get into surface area and volume in a later part of this unit, the formulas are more complicated, but if you understand the process, it's much simpler. Plus, doing it this way will make our calculator use a lot easier for anybody using Desmos calculator. So the process is you first write down the formula. So this is a parallelogram. So area is base times height. And then you go look at your diagram and any other information they give you and figure out base and figure out height. So in this case, you actually have a couple of choices. Which is the base? So if we choose 18 as the base, then the height will be 10. And then I can just plug in 18 times 10, which is 180. And they didn't give us units here, so I'm just going to write the word units squared. That's if I use 18 as my base, then the height is always the distance between, well, that other side, that other base. But I could have chosen this as my base. I could have chosen the 12. And if I do that, if my base is 12, then my height is, again, it's the distance between these two opposite sides. Remember how altitudes work. Sometimes you'll see them outside the figure, but it's just that perpendicular distance, which they're saying is 15. So if I make this be my base times height, you also will get 180 because it is the same area. So it just trying to show that it doesn't matter which one you choose as the base, as long as you're consistent with which one is the height. And very often we make that choice based on what we see in the diagram. In this case, it really didn't matter which one you used. Maybe this multiplication was slightly easier. Okay, second example, we want to find the area of a triangle. So area equals 1/2 base times height. It makes sense to use 21 as our base. Now, you could have chosen any of these to be the base. It's just which one do I know the height for? So if you choose a base, the height is you look at the vertex opposite and draw an altitude. So if I had chosen, say, the 13 or even the 20 as the base, but let's say I chose 13, then this would be the height that goes with it. I don't know that value. And I can make the same argument if I chose 20 as my base. So I'm going to choose the 21 to be my base. And that makes the height to be 12. So I'm going to plug that in. 1/2 21 times 12, which is 126 units squared. This one's a little bit trickier. This one, I actually know the area. And I'm given some kind of relationship between base and height. So the base is 4 times the height. So they provided a picture here for us, which is fantastic, but sometimes they don't. So you would have to draw one like it. Here is an example of what it might look like. The base is 4 times the height. So if your height is h, then 4 times h, that will be your base. So let's see, area equals 1/2 base times height. And they want base and height. They don't want area. We know area. I think the easiest way to do that would be to solve this formula equation for base times height. And you do that by multiplying both sides by 2, because if I multiply by 2, knocks out that 2 on the bottom there. So base times height equals twice area. So let's look at our base and our height. So substituting in 4h for my base and h for height, it's 2 times the area, which they gave me as 50. So this becomes 4h squared equals 100. Divide by 4, h squared will be 25, which means h is plus or minus 5. I'm going to reject the negative 5 because I can't have a negative side length, but my h then will be 5. And it says to find the base and the height. So this one is 5, right? And these are 5 inches. So this will be 4 times 5, or 20 inches. In this case, the base is 20 inches and the height is 5 inches. All right, let's look at a few more examples. This is a rhombus. So area of a rhombus is 1/2 diagonal 1 times diagonal 2. So I have to find those two values, diagonal 1 and diagonal 2. Now, because we're told this is a rhombus, it means it's a parallelogram, because all rhombuses are parallelograms. And in parallelograms, the diagonals will bisect each other. So that means that this segment here is congruent to that segment, and this one is congruent to that one. So if we're given this one is 7 centimeters, then this one will also be 7 centimeters. And if this one is 12 centimeters, then so is that other piece, because they're congruent. You choose whichever one is D1 or D2. So if I choose this one as D1, it's 12 plus 12, or 24 centimeters. And the D2 is 7 plus 7, or 14 centimeters. So now I know what to substitute in, which is 1/2 24 times 14. put that in the calculator or figure it out on your own if you're that good. I believe that is 168, and these are square centimeters. Try this one, finding the area of a kite. So for kites, let's see, I know that's going to be congruent to that, and this one's congruent to that by definition of what a kite is. So it's the same formula. It's still area is 1/2 diagonal 1 times diagonal 2. So I have to find these values. Now diagonal, if I make this one diagonal 1, it's pretty easy. You just add the 2 and the 8, you get 10 feet. But what about going this way? So if you remember your properties of kites, one of the diagonals does bisect the angle into two congruent triangles, and that would be this one, right? So these two triangles, this one here, around that one there, are congruent triangles. So this little piece here of 6 will be congruent to that part of the diagonal. That diagonal gets bisected, the other one doesn't. The second diagonal, if this one's D2, will be 6 plus 6 or 12 feet. So now I can substitute that in 1/2 12 times 10, which is 60, I believe. And these are feet, 60 square feet. And then finally, last example here is finding the trapezoid. So let's see, area of a trapezoid, at least the way I think about it, it's 1/2 base 1 plus base 2 times the height. The bases are these parallel pieces here, and the height is that perpendicular distance between them. So I have a bunch of stuff already, but I'm basically finding B1 and B2. So why don't I solve this for that? So the way I can do that is multiply both sides by 2 over h. Now why 2 over h? Because this 2 will cancel out that, and this h will cancel out that h, which gives us base 1 plus base 2 equals 2 times the area divided by height. And I'm going to substitute into this one because I think it makes things a lot easier than not doing that. So base 1, let's say that's x, and base 2 is x plus 3, is going to be 2 times the area over the height, which is 10. And I should put the area in rather than that a. So the area is 95. And that gives us 2x plus 3 equals 19. Subtract 3 from both sides, which means x is 8. So my B1, which is x, is just going to be 8 meters. And my B2, which is x plus 3, will be 8 plus 3, or 11 meters. So 8 meters and 11 meters are my bases. Okay, that's basically all I want to do in this particular video. In a second video, I have about finding area of regular polygons. So I'm going to skip all that for now. But you should watch that video, and I'm going to go right to these U-tries. Now, what I would like you to do is pause the video, and then I want you to try these U-tries. Do U-tries A through E, and pause the video to do so. When you've done the U-tries A through E, then you can turn this back on. So go ahead, pause it. Okay, we're back. If you still haven't paused it, go and pause it and try this. But if you have and you just want to check your answers, we can certainly do that. So this is a parallelogram. And if you just went into your calculator and put the answers down, you're really not getting the point here. We're just learning how to work with formulas and how to make our substitutions. So if you're just, again, going for the answer, I think you're going to have trouble when we do our next unit. So do all these steps. First one is you write down the formula. And it's a parallelogram, so that's base times height. Then you look over here and say, well, what's the base and what's the height? Now, if you chose base to be the side that says 20, that's a good choice, right? Because I know what the height is. The height would be 11. If you went and chose 12 as your base, well, I don't have enough information to know what that perpendicular distance would be, so that would not be a good choice for this one. So it's 20 times 11. You should have gotten 220 square units. And I'm sorry that this is so messy looking. I am using Not the best tools to make this video, so thank you for being patient. Find x in the parallelogram if we know its area is 70 square feet. So you still start with the formula, which is base times height. Now I'm looking at this picture. X is actually the height, so I want to solve this for height, which means divide both sides by b. So height is area over base. Now make your substitutions. So the area they gave us is 70 square feet. And then the base, if you're using this as your height, the base is this piece here, 10 feet. So this will be 7 feet, and that will be x, the height. Third one here is area of a rhombus. Area is 1/2 diagonal 1 times diagonal 2. Reminder that this is one you are going to have to remember because it's not on the formula sheet, at least not in the Commonwealth of Virginia. Again, it's a rhombus. If they didn't tell me, I knew that because I could see by these markings that all the sides are congruent. So I could tell it's a rhombus, which means it's a parallelogram, which means that the diagonals bisect each other. So this piece here is congruent to that, and this piece here is congruent to that. So if this is 12, so is that. And if this is 18 meters, so is that. So diagonal 1, if I make it this one, that's 12 plus 12, which is 24 meters. And diagonal 2 going the other way is 18 plus 18, which is 36 meters. And now we have all the pieces we need. So it's going to be 1/2 24 times 36, which is 432. I think, if I put everything in correctly there, and these are square meters, it's an area. And again, if you're just watching along here, you don't have a hard copy, go ahead and pause, do the problems, and then come back and restart. So hopefully you've done that. And now we are looking at a kite. Find x in the kite, given its area is 72.25. So always start with the formula. So area of a kite, one that we have to just remember, not on the formula sheet, 1/2 d1 times d2. For this one, it looks like diagonal 1, let's say that one's diagonal 1, and diagonal 2 are the things we need to find. So I'm going to actually solve this for diagonal 1 and diagonal 2 by multiplying both sides by 2. Because multiplying both sides by 2 cancels out that half. d1 and d2. So if I multiply these two things, it's 2x times x equals 2 times this area of 72.25. So, oh, look, these 2's will cancel right out. I think that's the easier way to handle that part. So x squared equals 72.25. And it came out to be plus or minus 8.5. I'm going to reject the negative, because if I use negative 8.5, I'll get some negative side lengths. So I'm going to reject that. So x is positive 8.5. And these are meters. Okay, next, one diagonal of a kite is 3 times as long as the other. We know the area of the kite, 384 square inches. What are the diagonals? Here's where you draw a picture. You must draw a picture. If you don't draw a picture, these are so much harder. You don't have to be a great artist. I know I'm not, but I know I have a kite here. So this would be congruent to that. That would be congruent to that. It's a kite. If I make this one, that diagonal, x units long, that means this diagonal would be 3 times as long, or 3x. So if I make one of these diagonal 1 and one of these diagonal 2, I now have some values. So we write down the formula, 1/2 d1 times d2. And again, I want diagonals, so I'm going to solve this for d1, d2. It just makes things a little bit simpler. Multiply both sides by 2. So d1, d2, so 3x times x equals 2 times 384 square inches. So this is now 3x squared equals 768. Divide everything by 3. X squared will be 256. Oh, well, that's nice. We like our perfect squares. So that means x will be plus or minus 16. I'm going to have to reject the negative 16 because I don't want a negative side length. So that means x is 16 inches, and that's one of my diagonals because it's asking for both. The other one will be 3 times that. The other one will be 16 times 3 or 48 inches, and that will be the length of the diagonals. I do want to just quickly mention how the Desmos calculator can help us here. So I have the Virginia version of the Desmos calculator, graphing calculator. It's very much like the normal version of it. Here's a cool thing you can do with Desmos. So let's say you were trying to find the area of, we'll make an easy one. Let's say I just want the area of rectangle, base times height. So I can just type in the formula. And if you look over here, see that thing where it says all? So if you click on that, it makes these little sliders. So you can put little values here, or you can just type it in. So one of the examples we did, the base was 12 and the height was 15. So it will do, I'm going to go back up to the top here. It makes the substitutions for you. And so the area is 180 in that case. So it's very nice. If you can use this process of you write the area formula down first and then find the different pieces of that formula, Desmos will do all that calculation for you. You don't have to worry about making calculator errors. So I just wanted to point that out if you don't really know that yet. Other than that, that is the end of this video. I hope it was helpful, and thank you for watching.